my name's Todd Backus. I'm a professional engineer. So for the hydronic course, we do require that you take the heat loss, heat gain calculation course. That's pretty standard with a lot of our courses, just to make sure that you have the fundamentals and you understand, where the envelope loads are coming from, and you have a solid base so that when you move on to the design, you have a solid foundation. For certification, it's been about 4 years since we've run the hydronic design course. Some of the certificate holders have had their certificate for well over a decade, probably verging on 2. And we are asking that current holders do go through a recertification process. So achieving the certification, there's 2 ways to do it. You can either take the course or you can challenge the exam. Obviously, for designers that have been, staying current in the hydronic industry and keeping up with their training, we expect that the majority of them will be challenging the exam and, not investing the time and money in the course. We obviously recognize that's a bit of an inconvenience, maybe even a bit of an irritant to go through with the recertification process. But we do really want to make sure that we establish a solid baseline for this certificate, especially because this sort of certificate is starting to gain a lot more weight than it's had in the past. So we want to make sure that we can stand behind our designers and say, you have met the competencies and you are fully certified to do this kind of work. So challenging the exam, essentially what we would be asking you to do is take a heat loss calculation results page. You'll have some parameters from a theoretical client, and you basically complete a system design, obviously not quite from the ground up, because we'll have to shave a bit of time off for the sake of keeping it a reasonable length. But if you are a competent designer, you study the material, you should be able to come through with a challenge without any major issues. We are also extending a 2-year grace period, so you don't have to go rushing out and completing this immediately. The revisions to the hydronic design course. So the course is going to be 48 hours of class time. There are 4 assignments and a final exam. There are now 3 manuals that'll be included with the course. So there's the hydronic design manual. There's the hydronic piping handbook, which has about 300 schematics in it. And then there's the Hydronic Combo Guidelines, which is significantly shorter, but all 3 of them together, probably about 600 pages or so. So some of the sections that we've added and expanded upon are expansion tank sizing, domestic hot water equipment sizing, domestic hot water recirculation, snow and ice melt, and pool and spa design. We've also gone through and revised a lot of the material in the manual. You can see the graph on the right is coming through nice and blurry, and it's very busy. So we've gone through and revised all of these graphs just to make them more clear and put them in a format where, when they get put into the manual or on a slideshow, they're coming in nice and crisp. We've added color for clarity. In the past, we avoided using a lot of color because of printing, but we've decided to err on the side of clarity. Similarly with the tables, we've gone through, checked all the tables, tried to pick up any errors. As we all know, the odd wrong number gets in there. So clean them up, reformat it so that they have nice headers. All the units are nice and clear and just a little bit more legible. We've also gone through and revised the checklists. We feel that this is really important because with some of our other initiatives, like in particular the ventilation guidelines, we found a lot of success with just having that become almost the industry standard for submitting those checklists. All the designers know exactly what they're expected to provide. The building officials know what they're getting and they can read it. And it just helps. It helps with the design process because it's set up to just work through top to bottom, step by step, nice and clear what your intentions and your values are. We've also revised a lot of the diagrams in the manual. This one is from the from the Hydronic Piping Handbook. So obviously we've just brought some of those over into the hydronic manual to highlight, some design decisions and some layouts just for educational purposes. So expanding on the sections of the manual, the expansion tank sizing we felt was maybe a little bit lackluster. I'm sure a lot of you have used some of these website tools before. I certainly have in the past. But we feel that, taking 2 points of information like the boiler net output and the type of heat emitter and then sizing off of that is maybe not the most accurate or professional way to go about doing it. So we've introduced a section on how to complete this through calculation. We've tried to lay it out as clear as possible because it's significantly more accurate. It's a lot easier to defend your decision, and you're going to end up with the correct size. So we've included several examples and a design checklist just to help you through that design process. We've also added a section on domestic hot water equipment. So we go into detail about sizing equipment for the domestic hot water tank. We talk about different elements like continuous recovery, the first hour recovery. We give some examples on tankless and tank designs. We also cover estimating combined domestic hot water loads and some design considerations around priority or non-priority for your water tanks. We've also included a section on calculating loads for irregular fixtures. So if you have some odd shower that has some very large flow rate or, some kind of soaker tub and you're trying to figure out, what you need to serve this irregular fixture, we have some calculations in there for you so that you can make an educated guess. Domestic hot water recirc. This is certainly something that I've seen a lot more of in the last few years, and it hasn't been the easiest thing to find good information on. So we've added a section for sizing that equipment, the design considerations, and also providing examples so that you can work through it, get your pipe sizes, know what the requirements are, and make an accurate selection. We've added a section on snow and ice melt. It's actually a rather large section. We know that you're not going to be doing this on every single project, but we thought that it added some value. Maybe this allows you to do some design that you might have in the past foisted off onto some engineer or technologist. But we thought that this was a nice addition. So we go through the full design process for a couple examples, and obviously talking about the considerations, the calculations for sizing the system, and then analyzing the output and understanding, what that is telling you about your system and what the implications are. We've also included charts, tables, checklists, all the necessary information to complete the design. And we've provided some complete examples. This is something that we're going to be asking you to take a look at too in some of the assignments, just to make sure that everybody's comfortable and qualified with doing this type of design. So pool and spa design, we've added a large section on that. We talk about heat exchangers, some of the typical set points that you might see, calculating loads and what the implications of those loads are. So there's the maintenance heat to maintain the temperature, and there's also the warm-up heat. And one of the things that we look at is that time that you're allotting for that warm-up heat, because if you want it to heat up very quickly, that's going to result in you requiring a very large heat source. So maybe that's something you can talk to your client about. If they can accept a longer waiting period, they might be able to reduce the size of that boiler. And obviously we go through examples. We cover hot tubs, we cover pools, and understanding those two different styles, you should be able to create a custom solution to the pools and spas. I'm going to talk a little bit about the permitting process and some of the issues that we've had with it. So I'm sure a lot of you have noticed some inconsistencies with some municipalities and their requirements for their submittals, and some of the maybe less resource-rich municipalities have had some issues with inspection process, and we're trying to create a clearer process for them so that they understand what the key items are. And there's also some consistency, because nobody really likes surprises. If we're all on the same page, that really helps a lot with just consistency. So this is an example from the city of Burnaby. In this plumbing and hydronic permit application, they're asking for heating installer trade qualification, heat loss calculations, boiler capacity, and there's a small line there about heat emitters. I think this is valuable information, but to me that seems a little bit light on information, especially when you consider that it's not asking about pumps, it's not asking about, maybe there's more than one kind of heat emitter. It's very light, but at least they are collecting some information. The city of Vancouver has retained a lot more control over their municipal process than other municipalities. We're definitely seeing a heavy push towards electrification and heat pumps. They've made it very clear that they are moving towards electrification, and it seems to me that their permitting process is getting a lot more structured and stringent. So do expect that they'll be asking for heat loss calculations. I anticipate that they'll be asking for heat gain calculations as well when you're going into cooling. They want to know the system type, and I'm sure a lot of you have come across already that they actually do require the municipal heat pump training when you're installing heat pumps. So just touching on that course briefly, the municipal heat pump requirements, that course actually you're supposed to take hydronic design. That's been a little bit of an issue for us because we haven't put it on since this course has been in the rotation. So going forward, we're going to be asking people to make sure that they complete the hydronic design course or challenge the exam before they enter into this program. And similarly, you still need the heat loss and the heat gain course. But for the municipal heat pump certification, you do need a trade qualification. So that's plumbing, gas, or refrigeration. Or you can have a mechanical engineering professional certification, or be an engineering technologist because you'll be familiar with the design process. So we do lean heavily on the building code, BCBC for most projects, NBC for anything on federal land. But we would like to see municipalities collect more documentation and just be a little bit more consistent across the board about what they're asking for. So we want to see that designers are certified and qualified. We want to see heat loss calculations. Your project should be detailed, so you're providing a summary of what's involved in the project by completing checklists, worksheets, and attaching that information. For drawings, a lot of Part 9 buildings really are light on drawings, so we're proposing an approach for acceptable system drawings, and for the inspection, providing a design summary inspection sheet. So specifically in the design certification, this does depend on the authority having jurisdiction, but basically what we're asking for is TECA or similarly registered design stamp on all of your construction documents that are submitted. If you're a professional engineer, you can obviously stamp these drawings as well. But really what we want is a little bit more accountability. So having a stamp with your name and your certificate number on it definitely provides that accountability. It's similar to what you see with a professional engineer, and it allows the confidence in the consumer and maybe some more reliable, consistent projects being completed by removing some of the, let's say, more problematic installers and designers. So TECA will offer stamps to everybody who has completed either the Municipal Heat Pump course or the Hydronic Design course or Ventilation Guidelines. In the BCBC and the NBC, it's actually been this way for a while. It does specifically state in Article 9.33.5.1 that heating equipment is designed to meet the parameters of the CSA F280 guidelines. This has been an item that has also been sporadically enforced, but based on my conversation with building officials and regulators, my understanding is going forward, they're going to be requesting this with much higher regularity, and they are making an effort to understand what these results are actually telling them. I do believe that this is going to, this section of the code is going to be amended to include cooling calculations, because they, again, want to make sure that systems are being properly sized and the calculations are accurate. So one thing to be aware of is a lot of calculators and software have not been certified. So TECA offers a heat loss, heat gain calculator that is certified by a third-party group, and that's actually quite critical, because if the authority having jurisdiction gets a heat loss calculation that is not certified, they could potentially raise an issue with it and say, well, how do you know that this actually complies with CSA F280? And that's very difficult to prove if you don't have that certification. So if you use our calculator, you're covered. There are some other calculators on the market, but just be careful, make sure that if you're using a different one, it does actually meet that certification, and check the version, because our version of the software, only version 5.0 and above have gone through the certification process. So if you have an older copy that's say 4.0 or below, you should actually upgrade to the current one. Our most current version is 5.04. And if you're using one of the older ones, you should actually upgrade to 5.04. It just came out a couple weeks ago. For acceptable system drawings, we are trying to create a little bit more standardization in this as well. There are a lot of different ways to do hydronic systems, and that's actually part of the problem too, right? There's a lot of confusion over the correct way to do things. So if you can provide a certified drawing that has been reviewed, there's some assurance that what you're doing is both correct and easy to inspect. So we do also recognize that what we've included, although it's literally hundreds of different schematics, there are different ways of approaching these designs, and we recognize that you might offer an alternate design, which is absolutely acceptable. So if it's stamped by a professional engineer, no problem. If you have drawn something up yourself, you can submit it to the TECA technical committee. We'll review it, provide any comments, and send it back to you. But assuming that it makes sense and is acceptable, we aren't going to hassle you for doing something slightly different. So this is an example. This is obviously a heat pump system, but what we're looking for here are the annotations to the drawing. So pipe sizes, you got various information about your incoming temperature, your equipment schedules at the bottom, your stamp, and we expect that this will be asked for at the building permit stage. And I recognize that some people might look at this and see like, that's a lot of extra work and it's kind of a hassle, but I would also ask you to consider that this is a very important communication tool. You can use this to communicate with your client, with the building official, with the permitting people. Like, this is a very critical part of your design, and the fact that it's being laid out and you just have to annotate it actually might save you a lot of drawing. Personally, I wouldn't want to draw that out by hand. So we've gone through with the checklists here. This is the same one I showed earlier, but we want to make sure that all the site information, the designer's information, which includes their certification number and their stamp, is filled in. And then this provides also just a little bit of a system summary, and you should be including your schedules, your equipment schedules. So on a lot of the drawings, there is a space for your equipment schedules, but anything that's not covered in there, you should actually be attaching with this and submitting. So some of the worksheets for, like this is an example of a hydronic radiant floor panel form. Basically what you do is you just work through it. You give the heat loss values that you've gotten from your CSA F280 approved heat loss calculations, your floor area, capacity, what is covering this, the piping, as well as any of the temperature information, your pipe sizing, lengths, the spacing between the pipes, number of loops, if you're using auxiliary heating, the size and capacity of the heat emitters, and again, the supply water temperature on the heat emitters. So this kind of information really helps the building officials because the plan checkers, I think, are well equipped to process a lot of this information. And if we can get them on board to review this in a timely and efficient manner, they can pass this information off to the guys on site who can then just show up and review and make sure that your submitted documentation matches what's actually installed on site. And if there are questions, it's very easy to just communicate and discuss what's changed on the project. Touching briefly on the inspection process. So I know that some municipalities follow this. Others have really struggled with manpower to actually make it out to the 3 different phases. But ideally, we should be seeing an inspector come around for the pre-pour, the rough-in, and the final stage. Pre-pour inspection, they should be checking against your submitted documents, making sure that your pipe sizes, centers, loop length, all that information matches what the design paperwork says. Help them out, provide labels for which areas are serviced, note down what your total lengths actually are, and make sure that the piping is secured and protected through the slab. And obviously a pressure test, because as you all know, encasing piping in concrete kind of removes the option of working on it at a later date. So for the rough-in inspection, basically they'd be going through the same thing, but just with the rest of the building, checking the insulation, making sure that the piping's isolated from the joists, and anything like a heat transfer plate has been properly installed. They should also be checking the location and the sizing of the piping on the heat emitters, baseboards, any of that equipment. And then there's the final inspection. So at this stage, they should have absolutely all of your paperwork, including noting down any changes to the project. They should be coming through and taking a look at, does your heat source information match your design requirements, the circulators themselves, and your mixing selection. All that should be consistent with the documentation. They're obviously going to be checking on any safety items, and we're going to be asking that you complete a commissioning checklist as well, just to show that the system has been properly started. And because we've seen a lot of issues around commissioning. You should also refer to your manufacturer specifications always. Sometimes they'll have very specific requirements, and if they have a checklist, fill it out, staple it, submit it, and always follow their recommendations. So I'd like to touch on the Hydronic Heat Pump Piping Handbook. This was just published. Actually, I believe the first copy came off last week. It should be going out to everybody who has taken the Municipal Heat Pump course already. It's got about 100 system diagrams in it. It's very similar to the Hydronic handbook, the piping handbook. So it's mostly just a collection of schematics. and this is now included with the Municipal heat pump course. So this is an example of one of those schematics. You can see there's like the equipment schedule at the bottom, simple layout. So you go through, annotate, and submit it with your plans, stamp and sign it. So this is on the load side. You know, it's similar to what you've seen in the other handbook, but it does have the relevant information for the inspector, so please do fill that out. And you should be able to find one that matches more or less what you're doing. They can get very complicated, so I fished this one out because it had just about every single piece of equipment I could imagine in there. And personally, I think that's quite a bit of value because it saves you having to draw it out by hand. It also shows that, you know, you are submitting a set of plans that's coherent and consistent and allows the inspector to check against these items very directly. We have included a mixing method section. So on the drawings, there is a section to note if you have mixing in there. You have several different options. So personally, I would staple a copy of this in there and highlight which method I'm using and just, you know, provide that clarity. Quick comment on controls. Do look into your controls at a very early stage. That is one of the biggest issues that I find on jobs where people complete the project and then they approach the controls as an afterthought. That is a very reckless decision. Do make sure when you are doing your equipment selection that you have a coherent control strategy. Maybe even reach out to the manufacturer or the supplier and get a little input. Because yeah, you don't want to get burned. You don't want to get burned at the end of the project. So this worksheet is included in the Hydronic Heat Pump Piping Handbook. This one is similar to the one in the hydronic design, but obviously tailored to heat pump installations. So on projects like this, you should actually be certified for both courses. And, you know, submit the relevant checklist. This one likely will supersede the hydronic one because you will be doing the heat pump as a source. I just wanted to talk real quick about a couple items for saving you some money on training. So Fortis BC has generously donated a large sum of money to offset the cost of training. So they're offering 70% off on our Forced Air Guidelines course and our Heat Recovery Ventilation Design and Installation course. Please be aware that it is limited to 2 registrants per course per company. So if you're running a massive company, please do not sign up every single one of your guys. We're trying to spread it around a little bit and make sure that you know, we spread that training out throughout the industry. There is an upcoming skills grant. Actually, it ran earlier this year for the, I guess that would be the fall of 2023. It is continuing right now, but you had to have signed up for it in the fall in order to continue to use it. So Work BC has put forward this Stronger BC Future Skills Grant. You have to be a BC resident, 19 years or older, and you can receive up to $3,500 for short-term skills training. One little bit of a catch for us though is it has to be delivered in a public post-secondary institution. So unfortunately, TECA cannot directly deliver this training because we need to meet that post-secondary institution. It hasn't been officially announced, but I do believe that in the fall, they're going to open this back up so that you can sign up for this $3,500. Also be aware that this does not necessarily have to be applied to construction. This could be applied to, say, office skills or some other skill. But if you look into it, it'll have all the details, and it's, you know, potentially quite a savings. So, with the assumption that this will be available in the fall, we've looked to create a partnership with BCIT to package a lot of our training with a little bit of theirs and create this residential air-to-air heat pump specialist micro-credential. So this would be eligible for that skills grant. So there's the heat loss, heat gain calculations, the principles of moving air, which is POMA, a new course, which is residential air source heat pump system design, and then followed up with the residential air source heat pump system retrofit design. So those are both our new courses coming out. And BCIT is working on a hands-on lab course. So they're going to do a really small class. Like from what I have heard, it's going to be about half the size of the other classes. And this air source heat pump installation skills will be a hands-on lab focused course. And that'll be the last course, so that you take, all of your understanding from the preliminary courses, and then you apply it in a practical way in the lab. So we're really excited about this. I think it's a great opportunity to get some training out there for you guys at a significantly reduced price. If you've taken the heat loss calculations or the principles of moving air through TECA, not a problem. You don't have to take it again. So you can just pick up where you left off and continue through with the micro-credential.